All right, so we're talking about for this unit, you're going to need to read a name and be able to provide a formula. So, just a quick review of that. I'm not a particular fan of a lot of what we're doing here, so let's just skip ahead here. The bottom line is we use for transition metals Roman numerals to designate the charge. Um, so, in this case, tin 2 nitride would mean tin has a +2 charge. And that's because the transition metals are not the ones we know. And the ones we know are group one are always +1, group two is always +2, silver is always +1, zinc's always +2, aluminum's always +3. So let's take a look at the periodic table. So this alkali metal, group one, they're always +1 by losing one electron. They become like the noble gas closest to them then. All of the alkaline earth metals are always +2 because by losing 2 electrons, magnesium losing 2 electrons becomes 10 electrons like neon. Calcium loses 2 electrons to become 18 electrons like argon. So again, being like noble gases by losing 2 electrons. So these are always +1, these are always +2. These are always -1, the halogens, because they're one away from their noble gas. The oxygen group, basically oxygen, sulfur, are -2 because they'll pick up 2 electrons to be like a noble gas. Nitrogen, phosphorus will pick up 3 electrons to be like that noble gas. +1, +2, +3 here. And then all these transition metals are the ones we'll use a Roman numeral for. And I kind of joked that it's kind of like the face of good cop, bad cop. You can see what's coming based on what Roman numeral is there. So here's copper 2 chloride. Copper has a +2 charge based on the Roman numeral. So you know you need 2 minuses to neutralize that charge. So there's +2, 2 minuses is a -2. Calcium sulfide, calcium's +2, sulfur's -2. So that would be the formula for that. Iron 3 nitride, the 3 is telling you iron's charge is +3. Nitrogen being in the group it's in is a -3 charge. So it's a 1-to-1 ratio for those to neutralize. Aluminum is +3. Iodine being a halogen is -1. So you need 3 -1s to equal the +3 charge of aluminum to neutralize that. So it's +3 -3. So the total charge is 0. Don't need to know those. So another way to look at this is puzzle pieces. So if you have the out puzzle piece here and the in puzzle piece for the negatives, since potassium's +1 and chlorine's -1, you just take one piece of each. And they fit and they neutralize each other. So the formula would be KCl for potassium chloride. For magnesium chloride, now you have +2 and -1. So you would want, you would have a puzzle piece with 2 notches in it. You would need 2 of the minuses to neutralize this +2 charge. So you would need 2 chloride to make that fit. And so that formula for magnesium chloride would be MgCl2. 2 chlorides and 1 magnesium would neutralize each other. You always write the positive one first, and then you can crisscross, which is another method we used if that puzzle was not working for you. Since magnesium has a +2 charge, you know that. You can put that +2 charge over with the chloride. And since that is a -1 charge, you would just take the absolute value of that, just the 1, put that with the magnesium. So it's 1 magnesium and 2 chlorides. You would then reduce to the lowest whole number. We drop the 1 since it's understood if you wrote it down that there's at least 1 there. So it would be MgCl2 for magnesium chloride. So here are the polyatomic ions. The only tricky one was this ammonium. It's a positive ion, even though it's made up of nonmetals. All the rest of these being negative would have, I know hydronium, but we're not going to really deal with that. All the rest of these being negative means they would be coupled with a metal. So you would always recognize this as an ionic compound, but ammonium having a positive charge, even though it's nonmetals. So you will have this list provided for you at all times. It shows you charges and names. So it's a lot easy. So for example, potassium carbonate. Carbonate is a -2 charge. You can look on that list, it's CO3 2 minus. So you would need 2 plus 1s to neutralize that -2. So it's K2CO3, potassium carbonate. Ammonium sulfate. Ammonium is +1. Sulfate is -2. It's on that list. So you would need 2 plus 1s, 2 ammoniums to equal the 1 sulfate, SO4. Those are just some more examples. All right, so that's a real quick go around. You need to know from the name how to figure out the formula, figure out the charge, balance the charges for ionic compounds. For organic molecular compounds, we might ask you for methane, ethane, propane, butane, pentane, one of these. Remember that every carbon makes 4 bonds. And so if you draw these molecules out, you would know that C has to have H4 and C2. So that's a carbon with another carbon connected to each other. If each one makes 4 bonds, that's one already taken care of. Each carbon then has 3 bonds left. So that would be a total of 6 hydrogens. The other way you can remember it is whatever the number is of the carbon, you multiply that times 2 and then add 2. So this is a 1, so 1 times 2 is 2, plus 2 is 4. This is a 2, 2 times 2 is 4, plus 2 is 6, so the H is going to be 6. 3 times 2 is 6, plus 2 is 8, so the H is going to be 8, etc. I don't know, again, how much of this I'm really going to ask you. The point was that if you take an AP, you do need to recognize from the name what it is we're looking for, or at least know that ethane is a CH, and hopefully you remember, as I said, that meth is 1, F is 2, prop is 3, but is 4, pent is 5. If you can remember the prefix and how many carbons are, that's really going to be helpful in your scientific life. All right. All right. So potassium phosphate. I think that jumped up a little bit. I don't think that was supposed to be right there. You need 3 potassiums. Sorry about that. 3 potassiums for 1 phosphate, because that's a -3 charge. You need 3 positive charges to neutralize it. And so when you write the formula, it's K3. There was 3 of these for 1 PO4. You can also do the crisscross. You write the metal first. The 1 goes to the polyatomic in this case. The 3 from the polyatomic charge goes to the metal. So it's K3 PO4 1. 1 is understood. You don't need the parentheses if you don't want around the PO4. I said I was happy to keep them there though. Ammonium phosphate. Ammonium is +1, phosphate's -3, so it'll take 3 ammoniums to neutralize the -3 charge. And that gets you this, and you need parentheses around here, NH4, 3 PO4. So it took 3 of these units. And you can crisscross there as well. That works. In science, we would drop these parentheses because the one's understood. But I said, since you're just learning, if you want to keep the training wheels on, just always keep parentheses around the polyatomics. I have no problem with that. Aluminum sulfate. Yeah, this is the ugly one. So aluminum's +3, sulfate's -2. So you're going to look for a lowest common factor, which is 6. So since you want a +6, you need 2 aluminums. And since you want a -6, you want 3 sulfates. So it would be Al2SO4 3. In this case, you would use the parentheses for the SO4 to show that all of those happen 3 times. And then write ions positive negative order still. So, and then you can crisscross these as well. Since that's +3, you bring that 3 over to the SO4. Since that's -2, you bring that down to the aluminum. Calcium sulfate, +2, -2, the charges are equal. So, or they negate each other. So you just need 1 of each. The crisscross here doesn't work as well. You need to remember to reduce when you crisscross to the lowest number. So 2 and 2 would mean 1 and 1. So it's calcium sulfate. No 2's necessary because we want the lowest whole number ratio. And that's what this is going to tell you. All right. We are not going to do covalent compound naming other than the organics and You should know carbon